Hussein, Nathan and C. I'll be taking you through network analysis. So before we'll do two examples. This is the first one, which is a bit simpler. Before we start, I'd like us to look at one important rule, which is two activities cannot come from the same node and end at the same node, like this. If these are my two nodes, I cannot have activity A coming from the same node and activity B coming from the same node. This is unacceptable. So this is what leads us to creation of a dummy. So this is unacceptable. So for us to do it the right way, we have to introduce a dummy, whereby if let's say we want activity A and B to come from the same node and end at the same node, but this way is unacceptable, we have to introduce a dummy, whereby it will be like, so this is my first node, this one, and this is my last node. So to introduce a dummy, I will have a third node. So my activity A, yes, will go directly to the last node, but for my activity B, it will pass through this third node that I've created, and for it to end here, I will now introduce my dummy. You will introduce a dummy activity line. So this will be a dummy activity. This is my B, this is my A. So this is the acceptable way. So I'd like us to do our first illustration. Okay, on to our first illustration. In this illustration, we have activity, immediate predecessors, and the number of days. So we'll start with, as you can see, we have A and B with no predecessors. So our first node, so we have activity A with no predecessor, activity B with no predecessor. Then C, immediate predecessor is A. So our C will come from here. So we have activity C. Then activity B comes from B. So we'll draw a node and ensure that this activity line touches the node. So activity D will come from B. Then the last one, activity E, comes from activity C and D. As you can see, this is our C and this is our D. So activity E comes from both C and D. So I'll redraw these lines. So I'll have a node here. Then this is activity D. This is activity C. Then we have E. Yes, now we've finished drawing our critical path. So this illustration, we are drawing the network diagram. Then we determine the early starting times and late starting times. Then the last one will be the critical path. And in determining the early starting times and late starting times, we'll get to our duration, project duration. So far, we've already drawn the network diagram. So we are going to the next part of determining the project duration. So for us to determine, we've been given the number of days, which A is 8, B is 2, C is 3, D is 7, and E is 6. So we'll subdivide like this. So in this case, I've subdivided like this so that the upper quarter will present the early starting times, the lower quarter will present the late starting times. So I'd like us to start. Our early starting time must always be 0. So in determining this next early starting time, it will be 0 plus 8, which is 8. For this one will be 0 plus 2, which is 2. Then this one will be 8 plus 3, 11. But we have 2 activities going into the same. So for us to determine, because we can use either this root or this root to find this number. So 8 plus 3 gives us 11, 2 plus 7 gives us 9. So for the early starting times, you pick the highest number, which is 8 plus 3 is 11, 2 plus 7, which is 9. So we pick 11. Then lastly, since we have one activity, it will be 11 plus 6, which is 17. So while coming back now with the late starting times at the lower quarter, they must always be the same. So you start again with 17. So as we go backwards, you'll take 17 minus 6, which will still give us 11. Then for this part, this lower quarter, it will be 11 minus 7, which is 4. This one will be 11 minus 3, which is 8. And then now we are going back to this one. But to determine this one, we have 2 ways. Either 4 minus 2, which is 2, and 8 minus 8, which is 0. Now, unlike the early starting times where you are going that way, when you come back, if you have 2 ways of finding this one, you pick the least number. For example, 4 minus 2 is 2, 8 minus 8 is 0. So you pick the least, which is 0. So, and you've determined the early starting times and late starting times for this network diagram. So, if you're asked, what is the project duration? Our project duration is the time at which all activities are ended, which is 17 weeks. That's the answer. If you're asked to determine the early starting times and the late starting times, in filling these quarters, you've answered that question. So this 0, 0, 8, 8, 2, 4, 11, 11, and 17, 17 are our early starting times and late starting times. Then the last part, which is determine the critical path. So for us to determine the critical path is where both the early starting time and the late starting time are equal. So in this case, we have, for example, this node is 0, 0, this one is 8, 8, this one is 2, 4. Because there is no equality in this, so this cannot be our critical path. So our critical path will be this one. So, and in identifying the critical path, you put some 2 arrow stroke. Then from here, the next one is 11, 11. So this is also part of our critical path. And then the last one is that one, which is that. So that means our critical path will be activity A, comma, activity C, and lastly, activity E. So why do we say it's the critical path is this? That means that these are necessary activities that must take place for you to finish the event. So you cannot function without activity A, C, and E. Hence, that's our critical path. Okay, on to our second illustration. So we have our activities, predecessor, and the number of days, and our questions are: draw the network diagram, determine the project duration, and critical path. Just like the other one, but this a bit involving. So I'd like us to start. Activity A, B, and C do not have predecessors, so we draw our first node and have activity A, B, and C. Then D comes from A. So this is A. So we have our D. Then E also comes from A. So this is A, activity A. So E can come from A. Then F comes from B and G, but we do not have G. So we go to the next one. So this one you put an asterisk. We'll come back to that. So for G, G comes from A and C. As you can see, this is our C, this is our A. So we can just shift this equal C to equal B. So A and C will give us G. So this is C and this is A. So that means if I take a dummy, where I'm using a dummy activity, this is because hatuwezi tumia straight line tena tuandike A. So this is still activity A. So activity A and C will give us G. So E may produce G. Then H comes from A and C. So this was A, remember, this is C. It will also give us H. Then activity I comes from D. So this is D. Then we have activity I. Then activity J comes from E, F, and H. But before we continue, we had forgotten this F. So since we have B and G, so tunaweza produce F. So F comes from B and G. G is here. So we can just shift this to equal H. This one becomes G. But now they should meet at one node. So I'll redraw this G and this B. B and G should give us F. So F. Then we continue. This way we had left. J comes from E, F, and H. We have E, which is hanging. We have F, which is hanging. We have H. All these three are producing J. So we can come up with a node, then converge all these three. So that F ikuja hapa. And then this H ifike mpaka huko mwisho. Then E pia ifike huko. So activity J comes from E, F, and H. So we've converged E, F, and H to give us activity J. Then the last one, activity K, comes from E, F, and H. So activity K also comes from these three. But now we have to draw our last node. So if we draw our last node, since activity K is our last activity, if we take K to this one, this is what I spoke about earlier. Two activities cannot come from the same node and end at the same node. So in this case, we'll create a dummy. This is where now our dummy activity comes in. So we'll have a third node. Then our K will go that way, showing that it has come from E, F, and H. Then since we can't have another straight line, so that's where we have our dummy line, showing that this is still K. Yes. And then the remaining one, which is I, which is also hanging, we also redirect it to the last node. Yeah, so this is activity I. So we finished drawing our network diagram. So our first question is done. Our second question is determine the project duration. But remember, in our first illustration, you cannot determine the project duration without finding the early starting times and the late starting times. So we can start from here, but we have to fill this number of days as we were given in our illustration. We have activity A, which is 8, 5, C is 3, D is 5, 6, F 6, 3, F is 6, G is 3, H is 10, 8, 12, 11, I, J, K. So I is 8, 12, 11. Now we can subdivide our nodes. So we'll start. Our earliest starting time must always be 0 because activity has just started. So our early starting time is 0. So we'll start with this one. To find this upper quarter, the early starting time is 0 plus 8, which is 8. This one will be 0 plus 3, which is 3. But remember, we have two ways of finding this upper quarter. Either this using this route or this route. And then remember, for any dummy line, this is 0. This one is also 0. So 0 plus 3 is 3. 8 plus 0 is 8. And we agreed that for the early starting times, you pick the highest number, which is 8. Then we go to this one. We have two arrows. That means we have two ways of finding this upper quarter, which is 0 plus 5 giving us 5 and 8 plus 3 giving us 11. So we'll pick 11. Then for this one, we have only one arrow, so it will be 8 plus 5 giving us 13. Then for this one, we have 3 arrows. This one, and this one. So we'll start with the first one. 11 plus 6 gives us 17. 8 plus 10 is 18. And this one, 8 plus 6 is 14. So our highest is 18. So we pick 18. This one is just one arrow. 18 plus 11 gives us 29. Yes. Then to find this one, we have 3 arrows. The first one, 29 plus 0 giving us 29. 18 plus 12 giving us 30. And 13 plus 8 giving us 21. So our highest is 30. So since this is our last node, that means at the end of this node, all our activities should be complete. So this shows the project duration, which is 30. So we've answered our second question. Our project duration is 30. Then we go to the last part, determine the critical path. So, but before we do that, we've not gone back to determining the late starting times. So for us to go back, since this is 30, that means at the end of 30 days, all these activities should be complete. So as we are going back, we will also start from 30. Then we go back. This is 30 minus 0, giving us 30. 30 minus 12, giving us 18. And then this one is 30 minus 8, giving us 22. Yes. Then we proceed to this one. We also have, this was just one arrow, so we only have one way of determining this lower quarter. 18 minus 6, which is 12. Then we go back. Now we can come to this. So we are determining this lower quarter. And to determine this, it has 3 ways. First of which is 22 minus 5 giving us 17. Then 18 minus 6 giving us 12. Then there's this one using the dummy, 8 minus 0 giving us 8. So we pick our list, which is 8. Then lastly, now to this last node, which was our first, we have 3 ways also. 12 minus 5 giving us 7, 8 minus 3 giving us 5, 8 minus 8 giving us 0. So to know that you've drawn the network diagram well, the early starting time and the late starting time must be equal, the same way with our last node. Then we go to our last question, determine the critical path. So how do we determine the critical path? We agreed that to determine the critical path, the early starting time and the late starting time must be the same. Okay, so in this case, this is the same, then followed by this and this are the same. Someone may ask, how do I know which one to pick? So for us to identify the right critical path, that means this led to this and this led to this. Therefore, this 0 plus this number of days for activity A must give us 8. If it does not give us 8, then that is wrong. For example, 0 plus 3 gives us 3, so it's not 8. So this cannot be our critical path. But 0 plus 8 gives us 8. So this is our critical path. You put these 2 lines to show this is the path we are following. Then from here, we have 3 arrows. This one, na hii. So ukiangalia, this one is already out because hazifanani. This one is in because zinafanana. This one is also in because zinafanana. So, but ndio tujue tutachukua hii ama ile, we have to add and ensure that it adds up. So 8 plus 0 gives us 8, but 8 plus 6 gives us 14. So iwezi kuwa hii. So our path will go like that. So we are here. So vile tuko hapa, the same thing. We have this arrow and that arrow. 8 plus 3 gives us 11, but here it is ifanani, so we cannot use that path. So this one, 8 plus 10 gives us 18, 8 plus 10 gives us 18. So this makes it our critical path. Then from here, we have 2 remaining, this arrow and this arrow. Automatically this one is out. So this one we confirm if it's adding up. 18 plus 12 gives us 30. 18 plus 12 gives us 30. And that completes our critical path. So if you do like that and it adds up mpaka mwisho, then you know you've drawn the right network diagram. So our critical path will be activity A. From activity A, then we have this. This is a dummy, so we cannot mention it. That means it is still A. Then the next one is activity H. Then the last one is activity J. So this is our critical path, showing that these activities are necessary. The whole event can happen with these others not happening, but they cannot function without activity A, H, and J. That's all. Thank you.